If y equal to 1 plus cos 2 theta all over sine 2 theta, find dy d theta. Solution. We're going to use the quotient rule. So we let the numerator be u and the denominator be v. So we're going to differentiate u and v with respect to theta. So we'll have that du d theta equal to 1 is a constant, it becomes 0. So we have cos 2 theta. In differentiating this, we differentiate 2 theta to have 2 times differentiating cos 2 theta, we have minus sine 2 theta, and that becomes minus 2 sine 2 theta. Now we're going to differentiate v with respect to theta. We have now differentiating sine 2 theta, we differentiate 2 theta to have 2 times differentiating sine 2 theta, we have cos 2 theta, and that becomes 2 cos 2 theta. Now we're going to use the formula quotient rule, which is dy d theta equal to v du d theta minus u dv d theta all over v squared. Now we're going to substitute them in the formula, and v has been given as sine 2 theta. We have sine 2 theta dot du d theta, which is minus 2 sine 2 theta. Then the minus sign here. Then u has been given as this, so we put it in bracket 1 plus cos 2 theta. Then dot dv d theta becomes 2 cos 2 theta all over v squared. And v has been given as sine 2 theta, so that becomes sine square 2 theta. Now we're going to multiply them and then expand the bracket. Sine 2 theta times sine 2 theta, we have sine square 2 theta. Meanwhile, we have minus sign here. So we have minus 2 sine square 2 theta minus, expanding this other bracket, 1 times this becomes 2 cos 2 theta plus cos 2 theta times cos 2 theta becomes cos square 2 theta. We have 2 here. So that becomes 2 cos square 2 theta all over sine square 2 theta. So we now have this minus 2 sine square 2 theta minus, as we expand the bracket with the negative sign, 2 cos 2 theta minus